In this video, we're going to go over using our special right triangles, 45, 45, 90, 30, 60, 90, and apply them to more than just solving for the lengths of those triangles. Okay, so we have an example, number 1, that we're going to look at, and we are given an isosceles trapezoid, and we want to find x. Okay, so we're going to start off by identifying the special right triangle formed inside the trapezoid. And this is going to happen when you draw an altitude. Okay, so I'm going to just real quickly draw an altitude from the end of the top base to the bottom base. Okay, so here we have a right triangle since it is a altitude. And we have a 45, 45, 90 to be exact because of that 45-degree base angle that we have. Okay, so we're going to use our properties that we know about an isosceles trapezoid such that our legs are going to be congruent. Okay, and then we'll also have that same altitude, if I draw it over here, forming a right triangle that is also going to be a 45, 45, 90 because your base angles are congruent. Okay, so in reality what we have here is two special right triangles with a rectangle between them. Okay, and so we are going to use the 45, 45, 90 here to help us determine the length of this side here. Because if I know that, then I can add it to that 9 as well as this length over here, which will be the same, to find my x. Okay, so using my 45, 45, 90, let's label with our ratios. Okay, so we have our s root 2, s, and s. Okay. So since we know that s root 2 is equal to 14, we're going to use that to solve for my s to help me find that x. Okay, so I'm going to start by dividing both sides by that square root of 2. It's going to cancel out, and then over here we're going to need to rationalize. And so we are going to get that s is equal to, currently we'll have that 14 root 2 over 2, which will just then simplify to s is equal to 7 root 2. Okay, so we have that this length here is 7 root 2. And with that being said, we can come back over here and we can take that my x is going to be equal to that 7 root 2 plus the 9, because like I said, it is a rectangle, and we know that our opposite sides are going to be congruent on a rectangle, plus another 7 root 2, because we know that these two lengths here are going to be congruent. Okay, and I just realized that I do already have one dash labeled, so I'm going to change this to 3. Okay, and so we're going to combine our like terms. Remember, we can only really add these two here because they have that same radicand, the same number underneath the radical. So 7 plus 7 is going to give me 14 root 2 plus 9. And that is going to be my x. Sorry, it was glitching. All right, now let's move on to number 2. Okay, and number 2, we are asked to find the perimeter of the isosceles trapezoid. Okay, so looking over here, remember perimeter just means we're going to add up all of our side lengths. Okay, so if we look here, this is an isosceles trapezoid, so we do know that this side here, or sorry, this leg, is going to be congruent to this leg. And then we already know that my top and my bottom base are going to be 32. Okay, so in order to find those legs, I'm going to do similar to what we did in the first problem, and I'm going to draw an altitude here that will allow me to use special right triangles to solve for that leg. Okay, so looking at what we have here, remember, we also know my base angles are congruent. And so we are going to have a 30, 60, 90 triangle. So I'm going to label with the ratio of that. So we would have our S, 2S, and then S root 3. Okay, but currently, based off what I've labeled with my ratios, I don't know any of those lengths, but I could solve for it. Okay, so remember I mentioned that this is going to be a rectangle. Okay, so that means that this length here to here is going to be 24. And so I'm going to subtract to find this S here. I'm going to take that 32 minus 24, and I'm going to be left with 8. Okay, now we want to keep in mind there are two S's, okay, because we have an S over here as well, that are going to be equal to that 8. So I need to take that 8 and divide it by 2 to find just one of them. All right, so my S is going to be 4. Well, with that being said, I know that my S root 3 is 4 root 3. And I know that my 2S is going to be 2 times that 4, which will give me 8. Okay, so now I know all of the lengths, okay, all the sides for this isosceles trapezoid. And so once again, remember, perimeter means we're going to add them together. So to find my P, my perimeter, I'm going to take 8 plus 8, the two legs, plus my two bases, which was 24 and 32. Okay, so combining my like terms, I've got that 8 plus 8 is 16, plus 24 is going to give me 40, and then plus that 32 will give me 72. Okay, so here we are finding perimeter. And so when we find our perimeter and our area, we're always going to have our units there. So I'm going to put 72 units. Okay. Now let's move on to number 3. Okay, so in number 3, we have the altitude of BD to the base AC of an isosceles triangle. Okay, so just before we move on, let's go ahead and draw this so we can get an idea of what we have. Okay, this can be a really bad triangle, but just bear with me. We have our isosceles triangle. We have the altitude BD, so B to D. To the base AC of an isosceles triangle ABC has a length of 12. Okay, so my altitude here, this length here, is going to be 12. If AC is equal to 10, we are going to find the perimeter of the triangle ABC. Okay, so once again, we have that AC has a length of 10. And we want to find perimeter, which means we are going to be adding up all of the sides of this triangle. Okay, so with that being said, we need to figure out what is this length of my congruent sides here. So we've got AB or BC. And so I'm going to focus on just one side of this isosceles triangle because I noticed that I'm forming a right triangle here. And so we can use Pythagorean theorem. So we're going to take that 10 and divide it by 2 to get the length of 5. And so we'll have 5 squared plus 12 squared is equal to c squared. So 5 squared is going to give me 25 plus 12 squared, 144, is equal to my c squared. When I add those two together, I'm going to get 169 is equal to c squared. And when I take the square root, I'm going to be left with my c is equal to 13. Okay, so with that being said here, we can find the perimeter by taking that 13 plus 13 plus 10. So 13 plus 13 gives me 26, plus 10 is going to give me 36. And once again, we're going to want to include our units. Since there is nothing provided, we're going to just use units. All right, now let's look at the back side for our next problem. Okay, in number 4, we have find the perimeter of a rectangle with a diagonal 17 and a width of 8. Okay, once again, I'm going to start off with a picture here. We have, it's a rectangle, so I'm just going to label a little bit about what we know. And it's got a diagonal length of 17. With a width of 8. Okay, so in order to find my perimeter here, adding up all my sides, I'm going to need to find the length. Okay, so I'm going to solve for this length here. And once I know that, then I can find my perimeter. Okay, so let's plug into our Pythagorean theorem since we have that right triangle being formed here. In case you can't see it. So we have 8 squared plus b squared is equal to 17 squared. 8 squared is going to give me 64 plus b squared equals to 17 squared, which is 289. When I subtract that 64 from the 289, I'm going to be left with 225. And so when I take the square root, I get that my b is equal to 15. Okay, so to find my p, my perimeter, we are going to add up. We've got that 8 plus 8, my 2 widths, plus my 2 lengths, so 15 plus 15, or if you know the perimeter formula for a rectangle, which is just your 2 times length plus 2 times base. Same thing, you're going to then get 8 plus 8 is 16, plus the 30 that I'll get from 15 plus 15 will give me 46. And once again, since there are no units here, we are going to use just the units. We always want to include that, and You'll see that happen a lot when we get into our area and perimeter units, as well as surface area and volume units in term 4. And so we're just easing you into it, just making sure you have your units on the end when you're finding that information. All right, let's move into number 5. Okay, so for number 5 here, we have a man travels. We've got 7 miles due north. Okay, so I'm going to just start off. We've got right here. And we've got 7 miles north. Okay, so I'm going to just go and label this as 7 miles. And then 2 miles due east. Okay, so I'm going to just draw this out. We got 2 miles east. Then we have that he's got 3 miles due south. And this doesn't have to be perfect, just getting an idea. Obviously, you know, the 3 miles south means we're going down. And since that is less than my 7, I do want to kind of make that length smaller. And then we have 1 mile due east. Okay, so we're going to go east 1 more mile. They're asking us how far is he from the starting point. Okay, so we are going to try and figure out from this point over here to where we're going to end up. How far is he? And so we'll be able to create a right triangle using what I've come up with. Okay, so here to figure out my lengths, I'm going to use my Pythagorean theorem to solve for this length. Then I need to figure out what is the distance between these two. Well, if we went up 7 originally and then down 3, we are going to get 4 when we subtract them. So we've got 4 here. And then, so just so you can see where we're getting that from, we got that 7 minus 3. Then to figure out the other leg to this right triangle, we have 2 plus the 1 is going to give me 3. Okay, so my 2 side lengths that I know, my 2 legs, are going to be 4 and 3. And we are going to try and find the hypotenuse of this right triangle to figure out how far away we have traveled. Okay, so we've got 4 squared plus 3 squared is equal to my c squared. 4 squared is going to give me 16 plus that 3 squared is 9 equal to my c squared. We add those two together, we're going to get 25. And so when I take the square root to find my c, I'm left with 5. Okay, so how far did he travel? We've got 5 miles is going to be my answer. Okay, so since this one does have units to go with it, we're not going to use that term units. We are going to use what they actually are measuring in, which is the miles. All right, now moving on to our final problem, number 6. Okay, we have the perimeter of an equilateral triangle is 36. So as always, just going to draw myself a visual. Okay, it's not going to be perfect, but I'm going to label it as a equilateral triangle. And for me, that's going to be me labeling in my degrees as well. So my perimeter is equal to that 36 units. We've got find the length of an altitude. Okay, so remember your altitude here is going to be starting at one vertice, just going to be perpendicular to the opposite side, which this is forming a special right triangle. And so we're going to use that to help us solve for my altitude. Okay, so since we know that we have a perimeter of 36, we are going to divide that 36 by 3. And we're going to be left with 12 for each length of my equilateral triangle. Okay. And so using my ratios, we know that this is going to be my 2s. We know that this right here is my s, and then my s root 3 is what I'm solving for. Okay, so if my 2s is equal to 12, I know that my s is going to be equal to 6. Okay, and so for my altitude here, we know that since s is 6, that s root 3 is going to be equal to 6 root 3. And so my altitude has a length of 6 root 3 units. Move over a little bit. Okay, and that is it for our lesson going over more using special right triangles.